try to rate a tornado.
And I would like to know why you can never get to the end of a rainbow.
What's the worst disaster in Iowa?
What are your top 3 movies that involve weather?
Welcome to Weathered Questions, where we answer the questions on your radar.
Welcome into Weathered Questions, the podcast where we answer the weather questions on your radar. Thanks for joining us. My name is Jan Kaj, joined by my co-host Kai O'Mara. We're so glad to have you with us for another half hour or so of nerding out over weather things. There's been quite a bit of tumultuous weather going on here recently across the gamut for the United States, from winter to spring and severe weather. So we'll get right into it here pretty quick, but we do want to encourage you to join in on the conversation. If you have questions or if today's show sparks any, you can submit those to weatheredquestions@gmail.com. That link should be in all of the different show notes for however you're getting your podcast. And thank you for all of your interactions, your emails, your feedback, your ratings, all of that. We love to see all of that, and it definitely helps the show get out to other people. So thanks for doing that, and thanks for telling your friends and family too. All right, Kai, let's get into it.
Largely, we're getting good reviews too, which means people must be liking this thing that we're putting on together here. But it's lasted a while, and you're right. The last 8 to 9 days have been really incredible. I think if I was a meteorology student watching it, I would really have a fun time. But even as a career professional, having to deal with it and watch it come through and see all the different impacts has been really, really interesting to see. Mm-hmm. And March has not disappointed in terms of big, sweeping lines of storms. And with that comes our cloud of the week, Jan. And the cloud of the week is going to be mammatus. Tell the listeners about mammatus.
Yeah, so we chose mammatus this week, and it is probably one of the most beloved clouds by meteorologists in part, but also maybe by the general public who don't realize what they are. They are the type of cloud that we always get so many pictures of. And so what a mammatus cloud is, it's a very smooth cloud. A lot of times it's described as like a pouch-like cloud that just kind of hangs down. So most of our clouds form from air rising upward, and mammatus clouds are a unique situation where it's actually cold air punching down through a layer of clouds, and it creates these little pouches all along. Usually those form in a part of the thunderstorm known as the anvil. So it forms kind of out ahead of or around the thunderstorm. Mammatus clouds themselves don't really give us any bad weather, but again, they form with thunderstorm clouds, and so typically they are associated with severe weather in some way just because of the timing. So a lot of times we'll get maybe a bad thunderstorm moves through, and then we'll get these really picturesque mammatus clouds with the sunset and cool colors that way. But yeah, mammatus clouds are a rare case of cold air sinking down, punching down through a layer of clouds that creates these pouches and these just really, really pretty, very smooth little cloud pockets overhead that, yeah, I mean, sometimes they can be not quite as defined. Sometimes they can be very, very defined. That's usually when we get those gobs and gobs of pictures sent in. And they're really fun to see.
The thing about them that's always very intriguing to me is when you talk about cool air descending, the reason why it's still able to condense and form a cloud is because you have such high humidity existing around it. And it just sinks down, and then eventually, all right, now we've kind of reached equilibrium around our surroundings, meaning that we're not going to go down anymore. We're also not going to go up anymore. We're just going to kind of sit there. But kind of universally speaking, if you see mammatus, there's probably a good chance that there's a good-sized thunderstorm near you. I'd say a good estimate within 10 miles, would you say? Is probably fair?
Yeah. I think that's a very fair estimate. So maybe you yourself did get the thunderstorm, but someone very nearby probably did. Yeah.
And if you're lucky enough to get them at sunrise and sunset, they will create a photo opportunity that you will never want to forget. Mm-hmm. You'll want to get out, take a look at it, grasp as many shots of it as you can, and they're really smooth too. They're not jagged clouds. They're very smooth pouches. Some people liken them to upside down bubble wrap. And in the age of Amazon and everything else being shipped, I'm sure you have bubble wrap at the house. And you just look at it. It's like the big pouches, not the small little guys, but the big ones that just poof, just sit there.
I've never heard the bubble wrap comparison, but that absolutely checks out. One other thing I'll mention here, because we've talked about the Latin names of clouds and how all our clouds come from Latin names, this is one, once I say this, you're never going to forget it now. The mammatus clouds, actually, it comes from the Latin word for udder. And so that's, again, if you picture that overhead in the clouds, that's what you're seeing. So yeah, it all checks out there.
Yep. Most definitely. Yeah. And last mammatus I saw was probably several years ago. But it was right here in my town, and it was it was just after a storm had passed. It wasn't before, it was just after. So really neat. And it was close to sunrise, if I recall. It's just a really, really nifty cloud that you do not see every day. That is for sure. Much less common. That's for certain.
I'm always on the lookout for them. I love seeing them. All right. Well, let's move on here. You know, we started the show talking about all of the crazy weather that we've had here in the recent past. And so let's dive into a little bit of that, kind of divulging some things that even if you're listening to this show, a couple weeks, a couple months down the line, I think it'll still be very interesting. So we've had here through the mid to late March timeframe across the entire United States, some pretty wild temperatures, as well as pretty wild weather in terms of both severe weather and even winter weather, blizzards and stuff. Do you want to unpack a little bit of that for us, Guy?
Sure. Yeah. And we're just going to pick a couple of stats on either side of the coin here, because it first really started with the record punch of cold that came in that I guess would have started March 14th or so. The 14th through 18th was kind of the window to see that. And there's a website out there called coolwx.com. And you can see a loop of all the global weather records out there. And they're shaded red or they're shaded blue in terms of dots as to who has seen what. And it's kind of a timely site, so you'd probably want to look at it in the next couple of weeks if you can. But that set off a whole bunch of record lows up in the northern U.S., Great Lakes region, and then even down in the southeast corner of the country, too. It got cold down there. And that was covered okay. I didn't see a ton of coverage on it, but just let you know, it did happen. That blizzard also happened in the northern plains. It shut down over 100 miles of Interstate 80 in Iowa, shut down Interstate 35 in Iowa. It dropped 26 inches of snow in Green Bay, which is the most since 1888 in one shot.
Yeah,
so
it was
think
wild.
about that. That's 140-year-old. Last observation of a storm of that magnitude. Marquette, I think, had 36 inches, and I saw a picture of somebody at our Michigan trip last year. We went to Detour Island for the first time. We'd never been to Detour, and that's way eastern side. And there was a lady who was walking up snow to get to her roof. That's how deep it is up there.
That's wild.
And that was covered to some extent, but probably not covered as well as it should have been. Yep. And the thing about weather is what goes up usually comes down. What's down is going to come up. And it has to do with usually what's called the amplitude of a wave. If you think of a wave crossing in front of your face, it's going to have a crest and it's going to have a fall. So it gets really warm on the eastern side, really cold on the western side. And so that blizzard happened to be kind of on the western edge of a fairly robust, what we call short wave that comes across. And that generated a whole truckload of severe weather, 1,200 damaging wind reports from the Ohio Valley to the northeast U.S. That occurred while the blizzard was happening. And that was its own animal. I mean, that thing was just a monster. Then you fast forward a few more days. All right, if there's record cold and a blizzard, you should probably look somewhere for either record heat to be happening or developing. Phoenix, Arizona, hit their earliest 100-degree reading and broke the old record by 8 days. Des Moines, Iowa, hit 90 degrees. This past Saturday, March 21st, beat the record by about 10 days for the earliest 90 on record. So there were dozens of record highs set there too. And that's pretty impressive to see it go up and down like that. But you do realize that it is a fairly even thing. If you're going to have a record cold air mass somewhere, chances are good you're going to have a record high. So it actually worked in the science pretty well. It just happened to be a really extreme situation. And I don't think the cold and the blizzard quite got the coverage it needed. So I'm trying to give it the coverage it deserves right now in this little forum that we have.
Absolutely. And I think we see a lot of that, right? Where, when you get those really big storms that impact usually the Midwest or the central parts of the country, they maybe don't get as much attention as things that are hitting the East Coast or the West Coast or those higher population centers. Naturally, if something is going to impact Chicago and airline travel there or something, it usually gets a little bit more publicity. But things that have kind of avoided those big population centers tend not to get as much. So since we can talk about it here and we can dedicate a little time to it, we figured we would. But
Of
yeah,
course.
all kinds of temperature records set recently. And one thing I do want to note, that we kind of glossed over a little bit, that those records were set a week ahead of where they have been set previously. So not only are they either all-time earliest temperature highs or just March highs or whatever, setting those a week ahead, not only is it like, oh wow, that's pretty warm for March. It's like a week to a week and a half ahead of schedule, which is pretty remarkable and definitely something to really think about. Just again, what that means in terms of temperatures and where everything falls.
Well, and not to mention the near 90-degree temperature swing over 5
Yes.
days.
Yes.
I mean, that was an incredible rebound. The plants have to be beyond confused right now. Like,
oh, absolutely.
The trees don't have a clue what's going on. So,
I know. I was,
hopefully
out
it
in
doesn't
my
affect
garden.
things.
Yeah, I know. I was out in my garden pre-blizzard, and saw my tulips starting to come up already. They seem to be okay. Didn't get too frostbitten on the tips or anything, but it will be interesting what how things come in this year and if anything was impacted by that because of early budding or something like that.
Right, most definitely. The other thing about this is there was a substantial severe weather risk issued, and it pretty much verified. There was a small amount of controversy that occurred on Monday, apparently. So this would have been 8 to 9 days ago Monday, just prior to St. Patrick's Day. We had a large moderate risk that was issued from the Storm Prediction Center, and it was mainly issued for strong straight line winds. And just that day alone, they had over 500 reports really concentrated in that area. And there were a couple of meteorologists out there that had gone out and said, hey, we messed this up. We apologize for this. And I guess Weather Service office did similar, but I'm not sure who the office was. And I guess there was also a forecast tornado threat with this that didn't quite materialize. And if that's the case, okay. But I think this goes into the further hazard simplification that we need to think about as meteorologists and communicators. So I doubt we have a single meteorologist listening to this program. I wouldn't expect a meteorology person to be doing that.
If you are, let us know.
If you are, let us know. But I expect that a lot of you are just everyday folks going to work, coming home, raising families, and just listening to us maybe on the radio or on your whatever place you listen to your podcast. And I think a very simple message on that Monday could have been, hey, a line of storms has already formed. And it had already formed. We're going to have some gusty winds of these today. Watch for them after 4 o'clock. To me, as a father of two, which I would have had to prep for my workday, that's a good forecast. And I think now when we've got 6 different categories of severe storms to consider or general thunderstorms to consider, plus now 3 additional conditional things that we're shading in, you have to think like, I have to say this very delicately, but I might just put it out there and just say, we aren't that good. I'll just be very blunt. We aren't that good at forecasting a specific threat that far in advance for that geographical area. And what it's going to do is it's going to create massive false alarms in the future. And we just saw one last Monday.
Yeah.
So there you go.
I'm going to take a step back real quick because I think a lot of people listening are, not necessarily super in tune with all of the changes in the meteorological world. So what's happened here recently is we've for a long time had these categories of ranking severe weather threat, from general thunderstorms to a marginal risk, all the way up through to those higher risk categories. Excuse me. And now we're adding in. And when I say we, this is all decisions, that are happening at a federal level. The National Weather Service is adding in these, and Storm Prediction Center, hatched areas in addition to previously existing ones, but just basically more ways to fine tune those categories and specify what may or may not be happening, which is a good thing in the sense of, trying to be as precise as possible. The problem is, to what Kai is saying here, we're sacrificing being precise for accurate. And, what is better? What is, the thing that's actually going to be more beneficial? And quote, what is right? Is precision right? Is accuracy right? Which way can we go, and which way is the better way to end up with that decision? So basically, we're just kind of taking all these categories and making smaller categories within them. But is that doing anyone any good is the question.
And this is before storms have even really formed, because
Yes.
that wasn't the only outlook this has happened to.
Yes.
And at that point, okay, that's if you're able to nail one, that's really good. However, does your average person even know that level of precision was forecast in the first place? And number two, why are we trying to be that precise? Because if you go anywhere outside of the US, anywhere, it's not nearly like that at all. And there may be a reason for that. Mm-hmm. It might just be, especially up in Canada, some lower population density, but they issue large severe thunderstorm warning boxes up there, like to the size of half of a state down here, like huge ones. And their general message is, be aware, there's a line of storms coming between 2 and 6 p.m. Here are the threats. Watch for it. That's what they do. And I think by getting so precise, we put ourselves in positions like that. So, for the meteorologists that did what they did, that's fine. It's okay. I don't know if I would have drawn that much attention to it. Like, there were 500 wind damage reports. To me, that's a verified forecast, right? Like, 500 reports.
And I think that's a very common perception of, it's just wind. Wind is still very damaging. We are all very familiar with how damaging straight line winds can be, with how damaging, especially Iowans listening to radios and things like that. Like, wind is still a verification of severe weather. Even if it wasn't a, mesocyclone tornado, that it is still verification of severe weather. And, not that we ever want that to happen, but if you forecast severe weather and big wind happens, then great, you got it right. Just an interesting take on the whole event, I think.
It is. And sometimes you think about, you don't have to see all the different cooks in the kitchen making the ingredients. You're going to a restaurant to get your meal. Just make sure the meal's good. Your service is good, and you can go home and leave. That's it.
Yeah.
You don't need to see every little thing that goes on under the hood. And I think by putting that out there, we put ourselves in a chance. It makes it just harder and harder to win in the long run. But
absolutely,
you know what? Doesn't really matter to either one of us in our current jobs right now. We got to do what we got to do. But I'm going to skip ahead a little bit in the show here, Jan. We're going to get to a listener from Des Moines. This is a follow-up from last season, actually. And then I think in our next episode, we're going to touch on tornadoes again. So this was mentioned in episode 3.3. And this person says, can you tell us more about the ITCZ? You mentioned it in episode 3.3 briefly, but it piqued my interest and I want to know more.
Yeah, so we talked a little bit about this. I'm trying to remember what all we were talking about back in that episode, but something hurricane related. I do recall that. And so this listener just wanted to know a little bit more. We, didn't dive into it too much. So If you haven't listened to that episode or it's been a little while, the ITCZ stands for the Intertropical Convergence Zone. So, a lot of big words. We just call it the ITCZ. So let's kind of dissect that. Intertropical, in the tropical area of the world, so down by the equator. Convergence, so where winds are converging or coming together from the various reasons that winds happen around the world. Again, trying not to get too far into it. And so this zone, this belt, basically all around the world, is where those winds are coming together. So where this happens, anywhere from about 5 degrees north to 5 degrees south of the equator. So there's about 10 degree of latitude. Got to make sure I'm doing my latitude and longitude right. About 10 degrees of latitude that will have this zone of converging winds. And what you might think with that is that it is, you've got all this wind coming together, that it's, insanely windy or something like that, but it's almost the opposite. It basically, there's, you get thunderstorms, something that we would more likely refer to as like our air mass thunderstorms that are just kind of popping up in the afternoon and happening and then kind of dying out. But otherwise, this area is fairly calm in terms of actual driving winds that are driving weather. And so as a result, there is not much that is moving our hurricanes or our systems around. And thus, we're not able to really get a lot of tumultuous weather in the ITCZ. So, there's nothing that's driving our hurricanes. You may have heard something, if you think back to high school physics class, the Coriolis effect. That is something that if you have a storm moving around the world, that's what kind of makes it start bending, start turning. That essentially doesn't exist in the ITCZ, and that's part of why hurricanes can't cross over the equator and can't go into that zone.
The other part about that zone is you're absolutely right. I believe it's nicknamed almost the doldrums in a way, because there's just not a whole lot of weather there.
Yeah.
They do get their pop-ups down there, but with the world being round and the way that hurricanes track and the way the Coriolis force moves, we don't. Yeah, in fact, you could look up a hurricane chart, a historical hurricane chart, and Google it right now if you'd like. You will not see a single hurricane track cross the equator. If it forms to the south, it's going to stay in the southern hemisphere. If it forms in the northern hemisphere, it will stay in the northern hemisphere, because you cannot all of a sudden change the way you're going to spin. It can't do like a do-si-do and cross the equator and then all of a sudden spin a different direction. That's just not how that works. So there is a little convergence there when that happens. Also, I will tell you that the weather there year-round, temperature-wise, is about the exact same thing every day. That you don't see much of a huge tilt of the earth impact down there. You see that a lot more kind of north of your 23.5 degree lines, as opposed to right along the equator, which tends to just be warm all the time. And especially with the warm ocean water that is typically around the equator all the way around, almost, with the exception of a few land masses, then you wind up just being about the same all the time. But that's what that is.
I Googled it. World Historical Hurricane Map. That's what you want to Google.
Yeah.
And you will get all kinds of fun little graphics they just have this space in the middle where hurricanes don't go. They just can't. They literally physically cannot sustain themselves there.
Yeah, it's a physics thing. That's all it is. Yeah. And we see Coriolis force all the time up here in the United States. And one great example of that is a high pressure system. When the air goes down, it spirals around to the right. Mm-hmm. And so that's why when our high pressure system's approaching from the west, our winds are usually northwest. And then when they highs go to the east, they turn back around to the south again. So we see it all the time.
Want a bonus experiment here for this episode before we wrap up.
Yeah,
take a Lazy Susan and put a piece of paper on it and spin your lazy Susan. Just pretend that's your world. Try to draw a straight line. Guess what? It's going to be curved every single time.
You're right.
That's how I teach Coriolis force. Because again, you try as hard as you want to draw a straight line. Slow it down. Keep it spinning. Even if it's slower, it's still not going to be able to draw a straight line. That's what's happening to our storms. They're trying to move straight, but the steering winds are causing them to turn.
Yep. And then the whole curvature of the Earth thing can mess around with radar beams. That's going to be for a different show, and maybe not even a show at all, because that's like textbook level.
That's
stuff
a
that I
whole
gotta deal with.
course in college.
Yes, it actually, radar meteorology is an entire course. But all right, you've made it now 25 and a half minutes into the show. We appreciate everybody for sticking around here. It's been a very, very exciting meteorological spring. So in meteorology, we tend to break it down just easily by month. And so March 1st is meteorological spring. And so we're deep into that right now in the month of March. And there's no sign right now that the ups and downs are going to quit. So we appreciate you hanging with us and sticking with us today. And we're always encouraging you to submit your questions. We will answer your questions on this program. We want to know what's on your radar. You can email us your questions anytime to weatheredquestions@gmail.com to join the conversation. In the meantime, we'll talk to you next week. Stay safe.